In the next section, we're going to work on arithmetic of matrices. This is such a nice section. It's fairly straightforward. As we're looking at these first couple of questions, what we really want to do is to set our entries equal. So we're finding the missing values. So this first entry needs to match up with the first entry in the next matrix. And because they're equal, we can pull off this equation, w minus 2 equals 6. If I add 2 to both sides, that tells me that w is equal to 8. I can also find x. Gosh, entry-wise, x equals 3, so that gives me x. Y, so this says that 2y, again, matching entries, equals 0. Dividing both sides by 2 gives us y equals 0. And then finally, let me circle these. Finally, we've got negative z. This very last entries equals negative 3. Divide everything by negative 1. And you've got z equals 3. So entry to entry, you can solve for those missing values. Similarly, in part B, I've got a little bit of work to do before I match up the entries, but I can add these entry-wise. So with this addition sign, I'm going to take x plus 1. I can create a new matrix, or you can skip that part, but this is what it looks like. X plus 1, 3 plus w, matching up these entries for the addition, y plus 4, and 3, z minus 2 will equal the entries, they're all 3s, 3, 3, 3, and 3. So as I work through these, x plus 1, entry equals entry, x plus 1 equals 3, subtract that 1, so x equals 2. 3 plus w also equals 3. Should we make those different? Subtract the 3's, so w equals 0. Y plus 4 equals 3. Subtract that 4, and y equals negative 1. And then finally, just a tiny bit of work on this one, those last entries. 3z minus 2 equals 3. Add the 3 to both sides. So 3z equals, add the 2 to both sides. So it looked funny. Add the 2 to both sides. So 3z equals 5. Divide by 3. And z, we'll just leave it as 5/3. Z equals 5/3. So really, really, again, just making sure that you're adding entry-wise and that you're also comparing, if you need to solve an equation, entry to entry. Add or subtract, notice it says if possible. I could only add these, I could only compare these if they had the same number of entries, if the dimensions were the same. So in part A, the dimensions are the same, and I can go ahead and subtract. My answer is going to be a matrix. So I'm going to take 1 minus 1, let me write out the subtraction. 2 minus negative 2, and then I'll write the solution here in a second. 5 minus 4, and then negative 2 minus 3, which would simplify to be 0. It becomes a plus. 2 plus 2 is 4. 5 minus 4 is 1. And negative 2 minus 3 would be negative 5. Okay, again, entry to entry. In part B, I've got 2 rows and 1 column. So this is a 2 by 1 matrix. But this one has 1 row and 2 columns. So this is a 1 by 2 matrix. These are not compatible. They have to be exactly the same dimension. So there just is no solution. It's not possible. So they have to have the same, and when I say, oops, I spelled it with 2 B's. So when I say the same dimension, I mean exactly the same shape. Okay, so subtracting, adding, comparing, all entry-wise. Get that misspelled word out of the way. Number 3, so not a lot of applications here. We will have some, but it gets a little more interesting when we start multiplying, and we'll do that later. But here's one example, and these are matrix bars, so I'll do that. Okay, so at a Kansas plant, a company produces cell phone cases. Leather cases have a cost of $4.46 for material and $6.61 for labor. Each plastic case, and notice we've got those labeled, $3.42 for material and $3.71 for labor. So we're going to go ahead and create a production matrix. So you can create lots of different kinds of matrices. The production matrix happens to have material and labors. A cost matrix might have several different costs for different areas. So a nice way to describe your information. So for the leather, we're just going to copy these over. 446 for materials. Labor, 661. Plastic, 342 for material, 342, really straightforward, and 371 for labor. Okay. Part B, suppose labor increased by 13 cents per item in Kansas, and material cost increased 38 cents for leather, so this is for leather only, this one's for both, and 42 for, oh, it says for calculator, this should say for plastic. Can you tell I copied a problem? So when I'm doing this, I want to, let's see, labor for both increased 13 cents. So 661 plus 13, 371 plus 13 cents. But for my materials, it increased differently, which makes sense, right? Leather versus plastic. So 38 cents for the leather. So 446 plus 38. And then for the plastic, it was 342, but we're increasing that for the plastic 42 cents, so plus 0.42. So if I just run through, I've just got my calculator off to the side here to make sure I get these correct. I'm just adding inside each of those entries to get those values right. And we get 484. And then I'm going to do 342 plus the 0.42. It's just really a matter of keeping everything straight. 384. And then as I add 13 cents, I get 3. I can do this one in my head. 374. Do that one in my head also. Oops, that would be 6. 674. And then the last one, 371 plus 13, would be 384. And you know what? Did I write that one down right? Yeah, I think so. So that would be your new production matrix. And this gets you through, 2.3 is a much shorter section. This gets you through section 2.3.